Hey there. Ever catch yourself staring at a coding problem like your brain just hit a brick wall?
Oh, yeah.
Yeah, we've all been there. Today, we're diving deep into something super relevant to you, building that mental toughness needed to crush those coding challenges. And no, we're not talking about like pushing your computer around or anything. This is about getting your mind in top shape, whether it's for a nerve-wracking interview or just leveling up your skills. From your notes, it seems like you're really interested in developing this mental toughness for coding. And honestly, some of the stuff in here is mind-blowing. So we're going to break down why this mental toughness thing is so crucial for coding, what practical strategies you can use to build it, and how to tackle those specific types of coding challenges that often trip people up. So to kick things off, let's talk about why this even matters. What's the big deal about mental toughness in coding?
Well, it's not about being tough in that old school grit your teeth kind of way. It's more about developing the mental toolkit you need to stay laser focused, manage the pressure cooker of coding, and solve problems effectively,
Yeah.
especially when the heat is on. Think about those intense coding interviews at places like Google or Amazon. That's where mental toughness can make all the difference.
That makes total sense. And you know what's interesting? Your notes mentioned something called a growth mindset. What exactly does that mean?
That's a fantastic point to bring up. It's all about shifting your perspective. Instead of seeing those head-scratching challenges as proof that you're not good enough or that you've hit your limit, you start to view them as opportunities to learn and grow. Mistakes, they become valuable feedback, not failures. And that struggle you go through while figuring things out, it becomes a sign of progress, not defeat.
Okay, I'm already starting to feel my mindset shifting. I love that reframing. Now, the article you shared is packed with different strategies for building this mental toughness. What are some that really stood out to you?
One that I've found incredibly powerful, both personally and with those I've mentored, it's the idea of simulating interview conditions.
Mm.
It's like anything else. Practice makes perfect, right? But here's the thing. The practice has to be as close to the real deal as possible. So setting yourself strict time limits when you're working on practice problems, talking through your thought process out loud. Imagine you're explaining it to someone else. Even asking a friend to do a mock interview with you. These can make a world of
It's
difference.
like game day for your brain, right? You've got to train those mental muscles. Speaking of training, there's a section in here about specific techniques for different types of coding challenges. What are your thoughts on that?
That's where things get really interesting. You see, different coding challenges require different approaches and thought processes. Think of it like having a toolbox full of specialized tools. You wouldn't use a hammer when you need a screwdriver, right? The same goes for coding challenges. The article goes into detail about various types, like array manipulation, string manipulation, linked lists. You've probably come across a few of these, and even something called dynamic programming. By understanding these specific types and the strategies involved, you're essentially building up your mental toolkit to tackle them more effectively.
So it's almost like having a game plan for your code, which is super helpful when you're feeling the pressure. But let's be honest, even with the best game plan, we all hit those mental roadblocks from time to time. The article talks about things like imposter syndrome and analysis paralysis. Can you tell us more about those and how they affect us as coders?
Ah, yes. Those mental gremlins, they can really mess with your head, even when you know your stuff. Imposter syndrome is that sneaky feeling of being a fraud. Like you're not as smart or skilled as people think you are, even when you have the experience to back it up.
It's that voice in your head saying, they're going to find out. I have no idea what I'm doing.
Exactly. And it can be paralyzing. On the other hand, analysis paralysis is more about overthinking. It's when you get so caught up in trying to find the perfect solution or planning out every single detail that you never actually start writing any code.
Oh, I've totally been there staring at a blank screen cursor, blinking, and suddenly I'm organizing my desk drawers instead of coding.
It happens to the best of us. The key with both of these mental blocks is to recognize them when they pop up and have strategies in place to combat them. We can dive into some of those strategies a bit later.
For sure, those strategies would be super helpful. But before we go there, I'm really curious about those specific coding challenge types you mentioned. Let's start with array manipulation. It seems like that one comes up all the time. What are some key things to keep in mind?
You're right. Array manipulation is a classic coding challenge. It's often used to test your understanding of fundamental programming concepts. The article emphasizes the importance of understanding those basic array operations, like adding elements, removing them, and navigating through the array efficiently. It also mentions some common patterns, like the two-pointer technique and the sliding window technique. These can be incredibly helpful for solving certain types of array problems.
Okay, those techniques sound intriguing, but I'll admit I'm not entirely sure what they are. Could you break them down a bit further?
Absolutely. Let's take the two-pointer technique. Imagine you have an array of numbers, and you need to find two numbers that add up to a specific target value. Instead of looping through the entire array for each number, which can be quite slow, you can use two pointers. One pointer starts at the beginning of the array, and the other starts at the end. You then move the pointers inward, comparing the sum of the numbers at the pointers to your target value. This way, you're efficiently narrowing down your search.
That's a really cool way to think about it. It's like strategically searching through a haystack instead of just rummaging around.
Exactly. And the sliding window technique is similar in that it helps you solve problems more efficiently. Imagine you have an array and you want to find the subarray of a specific length with the largest sum. Instead of calculating the sum of every possible subarray, you can use a window that slides across the array, adjusting the sum as it moves.
So it's like you're moving a magnifying glass over the array, focusing on one section at a time.
You got it. These techniques not only make your code more efficient, but they also demonstrate a deeper understanding of problem solving to interviewers.
That makes a lot of sense. Now, what about string manipulation? Any tips on how to tackle those challenges?
String manipulation is another common one. And the key here is to be comfortable working with strings in your chosen programming language. Each language has its own set of built-in functions or methods that you can use to manipulate strings, like finding substrings, changing case, or splitting strings based on certain delimiters.
So it's like having a set of specialized tools for working with text, kind of like a word processor, but for code.
Exactly. And just like with those array manipulation techniques, knowing these string methods inside and out can save you a ton of time and headaches. Another helpful tip for string manipulation is to consider using data structures like hash tables, especially when you're dealing with problems that involve counting frequencies of characters or checking for palindromes.
Hash tables, those are like super powered dictionaries for your code, right?
That's a great way to think about it. They can help you optimize your code and make it lightning fast.
I'm starting to see how understanding these different data structures and algorithms is like having a secret weapon in your coding arsenal.
Absolutely. And the more you practice using these tools, the more intuitive they become. Now, before we move on to some of the more complex data structures like linked lists, I want to emphasize something that's often overlooked in those coding challenges: edge cases.
Edge cases, those sound a bit ominous. What are they exactly?
Edge cases are those unusual or unexpected scenarios that can trip up your code if you're not careful. They're the what-ifs that you might not immediately think about when you're first tackling a problem.
So it's like thinking about all the ways your code could potentially break.
Exactly. And while they might seem like minor details, handling edge cases effectively demonstrates a deeper level of understanding to interviewers. It shows that you're not just thinking about the happy path, but also considering all those potential pitfalls. For example, what if the input to your function is empty? Or what if it contains negative numbers when you're expecting only positive ones?
So it's like having a mental checklist of what could possibly go wrong and making sure your code can handle it.
Precisely. And often addressing these edge cases reveals a deeper understanding of how things work, both in terms of the specific problem you're trying to solve and the underlying data structures and algorithms you're using.
That makes sense. It's like the difference between knowing how to drive a car and being able to fix it if something goes wrong.
Exactly. Now, are you ready to dive into the world of linked lists?
Bring it on. I'm ready to link up some knowledge. Link lists. They always sound a bit intimidating. What are they exactly, and why are they important for coders to understand?
Okay, imagine a chain of elements, where each element is like a link in the chain. Each link contains some data, but here's the key difference from an array. It also holds a reference or pointer to the next link in the chain. So instead of storing everything in contiguous memory locations like an array linked lists, can be scattered throughout memory connected by those pointers.
So it's less like a neatly organized drawer and more like following a treasure map where each clue leads you to the next.
Exactly. And while they might seem a bit more complex at first, linked lists have some advantages over arrays. For example, you can easily insert or delete elements in the middle of a linked list without having to shift everything over like you would with an array. That flexibility makes them really useful for certain types of problems and data structures.
That makes sense, but I can see how wrapping your head around those pointers could take some getting used to. The article mentioned something about singly and doubly linked lists. What's the difference?
Great question. A singly linked list is like that treasure map we talked about. You can only go forward. Each link only points to the next one in the chain. But a doubly linked list is like a treasure map with extra clues. Each link has two pointers, one pointing to the next link and another pointing back to the previous link.
So it's like having a back button on your treasure map. That seems pretty useful.
It definitely makes things easier for certain operations. For instance, if you need to traverse the list in reverse order, a doubly linked list makes it much simpler.
This is all starting to click. Now, the article also mentioned dynamic programming, which, if I'm being honest, sounds pretty intimidating. Is it as scary as it sounds?
I hear you, dynamic programming can sound like something out of a science fiction movie, but it's actually a really elegant and powerful technique for solving certain types of problems. Think of it like this. You have a complex problem that can be broken down into smaller, overlapping subproblems. Dynamic programming helps you solve those smaller problems once, and then store the solutions in a clever way so that you don't have to waste time recalculating them over and over again. It's like building a staircase to reach the top of a building instead of trying to jump there in one go.
So it's about breaking down a complex challenge into bite-sized pieces and then using those solutions to build up to the final answer. That sounds way more approachable than whatever I was imagining.
Exactly. And there are two main approaches to dynamic programming. Top-down and bottom-up. Top-down, or memoization, is like starting with the big problem and breaking it down, storing the solutions to those smaller problems as you go. Bottom-up, on the other hand, is like building your way up from the smallest subproblems to the final solution. It's like choosing between taking the stairs or building a ladder, depending on what works best for the specific problem you're trying to solve.
That makes it seem much less daunting. It's like choosing the right tool for the job, depending on whether you want to start big and break it down or build it up from scratch.
You nailed it.
Yeah.
And the article does a great job of illustrating these concepts with concrete examples, which I think is super helpful. Speaking of helpful, let's circle back to those mental gremlins we were talking about earlier, imposter syndrome and analysis paralysis. The article mentioned some really practical strategies for dealing with those.
Yes, please. I think we could all use some help in that department. Let's start with imposter syndrome. How can we quiet that voice in our heads that tells us we're not good enough?
Imposter syndrome is incredibly common, especially in fields like tech, where there's always something new to learn. One of the best ways to combat it is to reframe your thinking. Instead of focusing on what you don't know, try to focus on how much you've already learned and accomplished. Keep a journal of your successes, big and small. Did you finally solve a tricky algorithm? Did you learn a new programming language? Write it down. These accomplishments are proof that you're on the right track.
It's like creating your own personal highlight reel of coding wins to look back on when that imposter syndrome starts creeping in.
I love that. It's a powerful technique. And remember, everyone makes mistakes, even the most experienced programmers. It's how we learn and grow. Instead of beating yourself up over a bug or a setback, view it as an opportunity to learn something new.
So it's about shifting our perspective and turning those negative thoughts into positive fuel for growth.
Exactly. Now let's talk about analysis paralysis. That feeling of being stuck in the planning phase can be a real productivity killer. One effective strategy is to set a time limit for planning before you even start writing code.
So it's like setting a timer to snap yourself out of that overthinking spiral.
Precisely. Give yourself, say, 15 minutes to map out a plan and then dive into coding, even if it's not perfect. Remember, you can always go back and optimize later.
That makes a lot of sense. It's about getting out of your head and into the code, knowing that you can always refine and improve as you go. This has been such an insightful deep dive, and honestly, I'm feeling so much more equipped to tackle those coding challenges head on. Any final words of wisdom before we wrap up?
The most important thing is to remember that this is a journey, not a destination. There will be moments when you feel stuck, frustrated, or like you're not progressing as fast as you want to, but that's okay. Everyone learns at their own pace. The key is to stay curious, keep practicing, and never be afraid to ask for help.
I love that. Embrace the challenge, celebrate the wins, and never stop learning. This has been an amazing deep dive into the world of coding, mental toughness, and everything in between. If you're listening and you're about to tackle a coding challenge, remember what we've talked about today. You've got this. Until next time, happy coding.